Hello again and welcome to today's webinar about SBend issues we experience during calibration or most of the time operation stages. During this session, our primary focus will be to understand what SBend or curvature is and the reasons behind that. We will explore the various effects. So moving forward, we will discuss how these curvatures occur. Finally, we will focus on the practical aspects of identifying and rectifying SBend issues and our solutions to those aspects within software. I encourage all of you to actively participate in this training session. Feel free to ask questions, share your experiences, and engage in discussions. This is an excellent opportunity for us to learn from each other and expand our knowledge in this critical area. Once again, I extend a warm welcome to all of you. Thank you for joining us today, and I wish you a productive and enlightening training session. Let's start with what is SBend, because we all try to define this differently. SBend, or a curvature, is a non-corrected steering wheel movement during calibration or operation. Harsh and irregular steering movement resulting high offsets, mostly larger than 5 centimeters. Completely leaving the given trajectory suddenly or for a certain time and then return back to the roll. So all of these aspects are, we are trying to explain like this. So all of these are SBends. So what are the effects? Actually, we have mainly 5, we can inspect these under 5 major groups. The first one is mechanical aspects or effects. The second is software related. The third one is terrain. Of course, operational and signal related effects. When we talk about at the beginning of an installation or before the installation, mostly we should be aware of the mechanical aspects of the vehicle, not only the tractor or the most of the vehicles. So if there is mechanical effects from the vehicle itself may have some issues, or we may some issues during installation, or after installation and commissioning, there might be some effects from the implement side to causing SBend. From software side, if we are not aware well enough during the commissioning, we cannot enter some of the values or parameters. Actually, in this stage, the red border gives us the clue about the solutions, because we have solutions in parameters to correct this issue. So on the other hand, the terrain may also have some inclination and different types of soils. And during operation, the tasks are different than each other. Especially underlying the speeds of the task is so important here. And at the end, if we are getting the correctional signal from a GSM network or the signal from the satellite, positioning or heading, and of course, the signal status is another issue here. So let's start with the mechanical issues. The most of the part is coming from the old tractors, not the new ones. Those effects are due to mechanical conditions of vehicle itself. Within time, unwillingly, or sometimes intentionally. Yes, some people or farmers intentionally gives some space to steering wheels as well. System is only steerable, only vehicle is in good condition. What I mean is, if the front tires, most of the time for a tractor case, is not steered, then there's a dead zone because of the wear on the joints, U-joints or steering shaft or withdrawal, hydraulic system, etc. And the important thing of the traction is the center of gravity or the grip of tires. That is, I'm not talking too much on this because we will highly focus on the parameters and the solutions, but you should know that there will be effects all of the rest from the vehicle side. Let me show you an exaggerated video here. For instance, because of the implement, you see there is no traction because of the tire are not on the ground. So let me show you another. Sorry. Oops. Okay. So the balance width is important here. So, you know, the dead zone or the space on the steering wheel is so important issues at the beginning. Prior to installation, you should check whether it is dead or not. Is it in good condition or not? So another mechanical issue is the installation. During the installation, especially the spline sleeve are fitted well and not moving on 3 dimensions. Even the anti-rotational brackets may sometimes installed loosely or wrongly. So the motor shouldn't move in 1 centimeter. And last, we can say that the linkage or 3-point link to the implement side, the adjustable stabilizer arms on both sides may have some space, so not fitted well or fixed well. So that is another point that we should care about. And those 3 points in mechanical effects, 95% are in our concern. So please check before your installations around the vehicle about this effects. So when we come to the software sides, most of the time we are aware that the versions are not the latest one. So we have old versions. So those versions may have some problems in it. So you should be aware that the app version for the time being is 3.1525. And the ECU, we have 2 different versions. When you look at the about pages, you should see that all of the versions are like this. Especially the IMU version is important and the ECU is important. App is mostly related with the features, but ECU and IMU is for controlling the system. So 3.1316 or 2 ending with 228 is the same ECU for different type of terminals. So the IMU is the same, 30032 is the latest one. So the ECU and IMU should be consistent here. So we have motors and the version is 118 mostly. It should be, or lately we have newer versions 1190. So I'm not going into details of that. You should be changed to the latest version. So the second software effect is mostly coming from the wrong entry, the values, especially the GNSS receiver to the central access. For instance, someone measure as 2 centimeter, which is 0.02 meter because the field is in meter. But if we enter as 0.2 or 2 directly, which is completely different value than we need. So that means during calibrations, you will see turning to the left or right directly. So, or if someone changed this parameter later, the system will work abruptly as well. So another point is the no angle sensor situation. Most of us may not detect the limits of the, if we use no angle sensor, or we are not aware that no angle sensor is chosen. So the angle sensor detection is an important issue. So the steering speed ratio is automatically detected if no angle sensor detection is done. So another point is the calibration. During the calibration, we are not doing that one on a flat surface or a road. So that means at the end of calibration, we will have high roll and pitch angles offset values. So during the operation side, mathematically, these high offset will create another problem for us. So that is important for commissioning stages. So, okay, we have vehicle corrected, and now we installed entering some values to the related fields. During commissioning, we may forget, or especially for the harvester case, our system has some bugs and we will correct it in the following version. So we should be aware where the values are and what the correct values are. So next one is about the terrain compensation. Normally, it's not understood well. Here, the pictures are not shown. Sorry for that. Actually, the linkage problem, I think. So I see it's in my screen, on the other screen, but not in the first screen. How can I do that? So the terrain compensation should always be off position, because our system corrects it according to the roll angle, the side movements, I mean. So that is for the terrain compensation. If is on, that is for the side slopes. But that will be not good if it is on. So the system will always correct more if it is on, because the offset value coming from the compensation side, the calculation or the measurement done by IMU unit, so it will create more curvatures or offsets. So the terrain compensation is not used in the flat surfaces, side slopes. So actually here we should understand the exact solutions in our hand in the parameters section. So we can only change these three different values and correcting the SBend or behavior of the vehicle on the field. The commissioning coefficient, we have, you already know well that we have approach aggressiveness values. The first one is going forward, the third one is going to reverse. What is it? Actually, it is the value if we enter the higher values, the system tries to enter the vehicle to the waypoint or a row in a shorter distance or a shorter time. So usually all of the values are by default, it's 1, but usually after a while or at the beginning, farmers want to enter their vehicle to the line faster. So that means we can directly enter 1.4 to this value. But the more important than that, and should be checked over and over again, is the second value. That is the online aggressiveness, which is actually during the operation stage. If you want to, our vehicles are aggressive or not, then we should know that if we increase the value to a higher level, then the roll angles are detected in a shorter period and corrected immediately. But really, it is like this. If we do that and there are too many irregularities in the field, then it's nearly impossible to find a proper way or trajectory on the line. So that means sometimes, depending on the speed or the task, we should take care about this value. If the speed is low, then we may tend to increase this value and try and find the proper one. On the contrary, if the irregular fields or terrains we have, then we may need some less aggressive responses. So it's better to decrease this value. Mainly at the beginning, we are using this value as 0.8. But depending on the high or low speed situation, we should only change and see, review the behavior of vehicle, if it has more offsets than before or not. So online aggressiveness is the value most of the time we will check and correct or change. This is so important because there are actually 3 different values or parameters. Mainly we will change and see the effect. So this one is more important than the approach aggressiveness. Approach, as a summary, is the entry time. If you want a shorter time, we should increase. But depending on the different tasks, we should always take care or tend to change the online aggressiveness values in order to achieve the desired low offset values. I think it's clear. Well,
sorry. Can I have one question? Sorry for interruption, but
yes,
it's easier to ask when you are on this slide.
Yes.
I had I don't know about the others, but I had completely opposite solutions in practice. For example, approach aggressiveness. If the value is lower, then it's going into lane more faster. For example, on my tractor, I set it up on 0.4, and
Okay.
it's much faster. If I put it for example, on 1.4, it takes much more time to enter the lane. It's completely the opposite than it says here. I also tested this on other tractors that we installed, and it's the same. Also the online aggressiveness.
Yeah.
If I decrease the number, for example, 0.5, 0.6, then it's much more responsive. If I decrease the number, for example, 1.5 or 1.4, then it's less aggressive. So it's completely the opposite than it is said here, and
Yeah,
also in manual.
Yeah, I got the point, but I can easily say that this is not a fixed value. So it's a range and highly related with the other parameters as well. If we talk about the p-value, for instance, and if we think about the higher speeds, will it be the same value?
Yeah, I tested this also in low speed and in high speed, and it's if I'm decreasing, then it's much faster to enter the lane.
Well, we have been increasing. If I'm wrong here, because
it's with FGD.
Sorry.
The same issue is with FGD, the same logic.
So when you decrease,
the closest is to 0, the higher is aggressiveness.
So aggressiveness is to turning the wheel more left and right. Am I correct? More aggressive. When we say more aggressive,
yes, more aggressive if you're going to the 0.
Going to the 0.
Yes.
Yeah. Okay. So most of the time in Turkey, for instance, highly installation here, the behavior of the farmers at the headland, moving forward and backward to set the vehicle on a 0 offset. Is it the same for you, or directly going into the lane or row? How do you behave, or how do you drive your tractors when you turn to want to try to enter other row here?
How do you mean?
How do you drive your tractors when you enter the next lane, next row? Directly, or driving reverse and set the tractor on the row offset as 0 and then drive forward? Is it like this?
Yes.
So
I'm not driving in reverse. If you ask me, I'm not driving in reverse. Just
you are always driving forward.
Yes.
When
Just
you
going
turn.
in next lane. Yes.
So that means no reverse driving need to be corrected by the approach aggressiveness, right?
Yes.
Yeah. Okay. So depending
for example, I had a lot of complaint from the customers because the CHC nav takes really fast to enter the lane. And when I got first this manual, I set it up as default. This approach aggressiveness as default, I put it at 1.0, and with 1.0, it takes a lot of time to enter the lane. So according to the manual, I increased the value to 1.2, 1.3, and it was even worse. So we try to decrease the value, and when we go to do 0.5 or 0.6, then it's much better on the field, and much less time to enter the lane.
Okay, so since this okay, maybe you're right. Am I wrong? I'm wrong. So it's the value, it's the range to set and find the correct or wanted, desired situation. So it should be decreased or increased depending on the situation. As you said, in order to enter faster, it should be decreased. Thank you for your feedbacks. And is there anything about the online aggressiveness from your side? What is your experience?
Yes, also the opposite, as it was said here.
Aggressiveness, that means then aggressiveness is closing to the zero.
Yes, if you are going to the zero, it will be more aggressive.
Yeah, these are actually the understanding of this issue is a little bit difficult, really. Sometimes the aggressiveness of behavior, immediate behavior of a vehicle is really different. So we nearly use 90% of the installations as 1.4 here and 0.8 in online aggressiveness, and we get good results. So let's check together later on this, how will it be affected? So, and then correct it. Thank you for again. So the other parameter is the p-value. Always we say that as p-value. And this is also not understood well, or the confusion within time. This is also for, at the beginning, by default, the system gives you 20 value. There is no unit on this, since this is a coefficient and proportion. But think about the car driving on a highway in order to understand well if it is the correct example. If you drive 150 kilometers per hour, can you change your direction immediately? Of course not. So if you have higher speed, you cannot change the direction so suddenly. It may be very harmful for you. So it might be a crash there. So if the speed of a vehicle is less, then you need to turn your steering wheel more. So there is a different behavior here, highly related with the speed. So since the p-value is a coefficient, it gives you to arrange how it is steered according to the speed. So for such as seeding and spraying and fertilizing tasks, it's much more than 7 kilometers per hour. So no need to increase the value or turn more, let's say. So on the other hand, we can think vice versa, that the p-value should be increased if the task speed is less than 3 kilometers per hour. So while you are moving slower, then you need to turn your steering wheel more. Well, there is no optimal value for this p-value, but it's highly related with the characteristic of the vehicle and environment. Of course, it should be determined by you through the process of tuning and experimentation. You may have to change 2 or 3 times to find the exact value. So the dynamics of the system and the requirements of finer control is important here. The lower speeds can result in slower response times. That's why increased sensitivity because of that. Is it okay, or is there another question or any feedback of the p-value? So then I'm going forward. So sorry for that, because I can see on my second screen that the pictures, but this is something wrong here. So the terrain effects, as we can say that the soft and hard soils also will affect the roll angle at the beginning, and of course, the movements of steering. if there are soils hard in the same field and soft, the one tire on the ditches and the other one on the hill, so it is tilted, let's say, to the sides, then we have roll angles. The system will understand that it should be corrected to the according to the flat surface. So then most of the time we have been switching or moving sides inside the cabin of a tractor, let's say, and then we understand that, at least we realize that we are moving to the side, so the roll angle is changing. So you can also see or observe the data of the angles on the status screen on the left-hand side on the top of the control terminal. So you can see that how roll angle is changing, and at the same time, because of the default offset of angles, the tractor or the vehicle will move abruptly, unwanted way. So then we should understand it is because of the terrain situation. So on the other hand, the inclinations are also affecting this issue. For instance, this one, please check the terrain here. There are numerous of inclination in different directions here, and the farmers are using this territory to seed. So you see the bands here clearly. It's a difficult terrain for this. And let me show you the tractor screen. And please pay attention to the pitching and rolling angles here, how it behaves. You see 3 centimeters and increasing. So when you debug a situation like this of SBend, you need to know what are the angles here. Or do we have directions, headings, values? Or is it located well enough? So you see the tractor is losing its line up to 9 centimeters right now, but concentrate on the speed here. You see 0.6 kilometers per hour. So this vehicle has attitude angle sensor. So as you know, this is not within range of the sensor. So we need to change it to the whole sensor, so that we will have separately. So when you debug a problem here, you should take care of it. So I told the farmers that increase the speed because the inclination is upward, was upward at the beginning. And when he increased the speed here again within the range of the sensor, the offset has decreased to the desired range again. This is important issue. Someone may say directly it's a high offset, but slower speed, then we should take care of this. So as you see here, there are such terrains. Of course, the tractors may not work like a harvester, but we have also harvesters like that. But you can see that the terrain compensation is something like this. Otherwise, tractors or implements may not be used well here. So the next one is about the operational effects. Actually, on the other side of picture, The left pictures are for the slower tasks, sitting, but on the right, spraying. The slowest and the fastest tasks. So these operations also affect the offset values increasing while using different parameters. So if you increase the online aggressiveness with a higher speed, you may fail with the SBend. So on the contrary, if the task is slower, then you may need to increase the online aggressiveness to correct it immediately. Well, as a last slide, I can tell you that this is a hidden data or information that we cannot too much knowledge about this. That is the GSM network status for the entropy accounts, especially. As you know, the correction values are transferred over the internet. So not the parameters, but the latency of the data is important. Okay, we have some applications on the stores, iOS or Google Play. So you can test your network speed, but this is average values. There are two other parameters here because we are not on the always same situation. There are low or highest values, as in this case, the highest ping, that is the latency, reaching 3 seconds. Can you imagine this? So if you don't have the good RTK, it's mostly because of this. So this is download, this is upload. So one of them may fail within time. So we cannot directly see the high values of averages, but we can just look at the latency. On the other hand, the other value is the jitter. So I suggest you to download this network speed test application to your phones, and then you can easily find it is because of the network or not, for entropy accounts especially. On the other hand, again, the status page, we have the RTK status marked as red box here. So we may see the accept tree from 0 to 5. The normal condition is fixed solution, which is 4, that we need, or it's a must value. Sometimes we may see that the RTK status is 5. That means it's a floating point solution. It means that, okay, there is a correction data, but not moved to the highest precision mode yet. So it's not fixed, in other words. The other two, not connected, it's not connected to enough satellites or the ground bases. And there are also, because of the decomposition of the satellites GPS signals, it is shown as 2 here. So this is the end of the training session. I tried to list the effects of the SBends. So we need to check all of these conditions and the values and the data in order to achieve a good result for farmers. So this is an utmost attention because if any farmer has this issue and not corrected, mostly he wants to return the kits back. Thank you for listening to me, and now we can pass through the question and answer session and your experiences as well. Yes, anyone wants to join us? Any speech? Yes, Miloš? Or Gabriel?
Yeah, I already asked.
Okay.
So maybe one more question regarding terrain compensation. Is it possible to be off as default?
Yes, possibly. So we also feedback this. I think the next one we will have the newest or latest version. It should be off there.
Yeah, okay.
You are so right then.
Okay,
No need
thank
to
you.
remember always.
Yeah. It will be easier much.
Yes, exactly. You're right.
Thank you.
How about Gabriel for you? Now you will go to a commissioning stage. Is it helpful
Yes.
for you, all of this?
Final phase for base station, RTK base station, and we follow the test on the field.
Mm-hmm.
And I will play with parameters to see what's happened.
Yeah.
I don't understand very well about the software version. It was old version there or a new one. Which version we should have on the
Yeah, let me
ECU
show
and
you
the
one more.
IMU?
Yeah, the latest version is this one.
Okay.
APP is 3.1.5.25. And
APP I know.
accordingly, this is a set of versions, ECU and IMU. So you should have the latest corrections, improvements, and features with this set.
Okay, then it's the latest. Okay.
Yeah. Whenever you install a new set, first start with the sharing in your group, your serial number, or directly check your remote assistant platforms and upgrade it.
Yes, I succeed from remote platform to upgrade until now. But there is a manual. It said that when you upgrade, when you make an upgrade of the system, disconnect, I think IMU.
No.
There is.
It was a motor upgrade. If it is the ECU is 3.1.3.16, then we should remove the black harness or second harness behind the terminal.
But it's not the
Not
case
to
with
harm our motor.
It's not the case with the latest versions.
Which one?
We shouldn't disconnect. We shouldn't disconnect nothing.
Okay, then your ECU is not this, then it is this. Check these two different ECU, completely the same on the behind, but on this version, starting with 103, no need to remove the harness. But if it is the ECU, it's starting with 3, then we should remove the cable. That is the difference. That's why you don't need.
Okay, it's clear. It's clear now. Thank you.
Okay. Yeah. Is there any other question about the SBend issues or any experience or knowledge how you corrected in the field, or how did you do that? Or most of the time, what is the condition that you will face after a new installation or after a while? Any suggestion, any experience here to share? Okay, I think it's clear. If something happens, it's so important issue, we will share this video on the YouTube channel, and as well, we can send you the presentation as well. So, thank you very much for attending this webinar, and have a nice day, all of you.